diagram, which is a circuit with resistance and potential value. This resistance, we're going to use those formulas in order to put it together. So, first one, we use resistance 3 and we have the resistance 4, which values are 6 and 4, and we added this with using that formula, and now we got 2.4 ohms. We simplify our diagram and put it together, resistance 2 and resistance 3 and 4. As a result, using that formula, we got 4.4 ohms. Now, with resistance 6 and 7, we add together, and we got 3.33 ohms. Our diagram is now more simplified, and we got only this resistance, the 5 and the 2 and 3 and 4. So we put it together using the parallel formula of the resistance, and now we got 3.22 ohms. And this is our diagram simplified.
Okay, now we have understood the problem, and we have simplified the circuit to its maximum possible. We can get the equivalent resistance, that is the sum of all these two resistance, and we get as a result 16.55 ohms, and also we get the voltage that we already know, that is 24 volts, and with that we can get the equivalent current, that is the result of the voltage divided by the resistance, and we get as a result 1.45 amperes. The problem is to get the current and the voltage of each resistance, we need to follow this flow chart with its sequence and logical procedure. First, the resistance 1 and resistance 2, 3, 4, 5 and resistance 6 and 7 is in series, so it has the same current. And with this, the resistance 1 is alone, we can get out the values with the formulas, and we have it here. Then the resistance 2, 3, 4 and 5 is in parallel, so it has the same voltage. As we know here, is 2, 3 and 4 in one resistance and resistance 5 in another one. So we isolate and we solve with the formulas and the values, and we get this result here. Now we have resistance 2, 3 and 4, and we separate in resistance 2 and resistance 3 and 4. So this is in series, so it has the same current, and we can solve for the resistance number 2. Now resistance 3, 4 is divided in resistance 3 and 4, as we see here. It's in parallel, so it has the same voltage, and we isolate and we can solve with the formulas and the values, and we get the results here in the table. Now resistance 6 and 7, that is the one that goes here in the initial diagram. It's in parallel, so it has the same voltage. We isolate each one, and we solve with the formula that we know, and we can get the results that are in this table.
The operation of the microwave is based on electric radiations, which cause water molecules move very quickly, causing friction heat between the molecules of the food. All foods containing water to a greater or lesser extent, making it possible to heat or cook any substance containing some water. Inside the furnace, there are an electric device called magnetron, produces microwaves or high intensity and transport them to a ventilator to be transmitted to the chamber where the food put.
The law of Kirchhoff, or the loop rule, around any closed loop in our circuit, the sum of the potential differences across all elements is zero. This law is a statement of energy conservation, in that any charge that starts and ends up at the same point with the same velocity must have gained as much energy as it lost.